Hello friends, today we are going to start the chapter Trigonometry, one of the best chapter of your geometry, mathematics part. Right? This is the sixth chapter of your Maharashtra State Board books, okay? Geometry. Let us start Trigonometry. We are going to divide this chapter into various parts. In the first part, we will be learning or we will be having a brief revision of what we had learned in our 9th standard trigonometry. That will be our first segment, which I will be calling as part 1. To understand that, let us first understand a right angle triangle, because as you know that the entire trigonometry is based upon a right angle triangle. Now consider a right angle triangle ABC in which we have taken angle B as 90 degree and angle A we have denoted by a Greek alphabet theta. Theta is used whenever we do not know the measure of any angle. As you know, in our arithmetic, wherever we do not know the value of any quantity, any commodity, any article, we consider it as x. Here we are considering as theta. The third angle is angle C. Now other than the 90 degree, in a right angle triangle, the other two angles are always less than 90 degree. That means both of them are acute angles, out of which one angle we have taken as theta. Let us find the measure of other angle. To find the measure of other angle, we are going to use the property angle sum property of a triangle, which says that the sum of the measures of angles of a triangle is always equal to 180. Accordingly, in place of A, let us put theta. In place of B, let us put 90 degree. And in place of C, it is as it is, because C is what we have to find out. Together, it is equal to 180. Taking 90 and theta over that side, we will know the sign will change. Therefore, angle C is equal to 180 minus 90, and this theta also has become negative. Therefore, angle C is equal to 90 minus theta. Also, in a right angle triangle, we know that the side opposite to the right angle is the hypotenuse. Therefore, in triangle ABC, side AC is the hypotenuse. This was a brief introduction of a right angle triangle. Now let us come back to our trigonometry. Now we know that in our 9th standard, we had learned 3 basic trigonometric ratios. They were sine, cos and tan. What were their definitions, remember? Their definitions were sine is always defined as opposite side upon hypotenuse. Now you wonder that whose opposite side, whose adjacent side, which hypotenuse, and so on. For that we require the reference of an angle, and that angle, suppose we consider it as theta, then sine theta is equal to opposite side upon hypotenuse. The side opposite to theta in triangle ABC is side BC, and therefore we have written over here BC, and here in place of hypotenuse we have written AC. This is the definition of sine theta. Similarly, cos theta. The definition of cos theta is adjacent side upon hypotenuse. The side adjacent to theta is AB, although AC is also the adjacent side of theta, but hypotenuse is never considered as adjacent side or opposite side to any angle as far as trigonometry is concerned. And therefore, we will consider adjacent side as AB, and hence we get the ratio AB upon AC. The definition of tan theta is opposite side upon adjacent side. Therefore, opposite side is BC, adjacent side is AB, and hence we get the ratio BC upon AB. These 3 trigonometric ratios we had learned in our 9th standard. In 10th standard, we are going to learn 3 more trigonometric ratios, and they are cosec theta, sec theta, and cot theta. Cosec theta is the multiplicative inverse, or you can call it as reciprocal of sine theta. Sec theta is the multiplicative inverse or the reciprocal of cos theta, and cot theta is the multiplicative inverse or the reciprocal of tan theta. Therefore, you can see that in the definition of cosec theta, hypotenuse is appearing in the numerator and opposite side is the denominator. Why? Because cosec theta is the reciprocal of sin theta. In sin theta, it was opposite upon hypotenuse. Therefore, in cosec theta, it will be hypotenuse upon opposite. Similarly, in the definition of sec theta, you will see that it is hypotenuse upon adjacent, whereas in case of cos theta, it was adjacent upon hypotenuse. Same way, in case of cot theta, it is adjacent side upon opposite side, whereas in the case of tan theta, it was opposite upon adjacent. And hence, we get the ratios AC upon BC, AC upon AB, and AB upon BC as the definition of cosec theta, sec theta, and cot theta in case of right angle triangle ABC. Right? Now, as we saw that cosec theta, sec theta, and cot theta are the reciprocals of sine, cos, and tan. Therefore, mathematically we can express them as cosec theta is equal to 1 upon sin theta, because reciprocal means 1 upon. It is vice versa. If cosec theta is the reciprocal of sin theta, then sin theta is also the reciprocal of cosec theta. Therefore, when you cross multiply sin with cosec, we get sin theta into cosec theta is equal to 1. Similarly, mathematically, sec theta can be written as 1 upon cos theta, and therefore cos theta can be written as 1 upon sec theta. When you cross multiply them, we get cos theta into sec theta is equal to 1. Same way with cot theta. Cot theta is equal to 1 upon tan theta, or you can say tan theta is equal to 1 upon cot theta. When you again cross multiply them, we get tan theta into cot theta is equal to 1. A very simple table to remember the definitions, because sometimes students have a habit to forget the definitions. So in order to recollect the definitions, memorize the definitions, remember the definitions, there is a small chart type of box we can say, in which you can see that I have written sine, cos, tan at the top, cosec, sec, and cot below. Now what do these O, H, A, H, O, and A represent? As a mnemonics, I have set this as old Ritik and his old Amisha. You must have seen the movie Kamuna Pyar Hai. In that it is like this: old Ritik and his old Amisha. O always stands for opposite, H for hypotenuse, A for adjacent, H for hypotenuse, again O for opposite, and A for adjacent. So it is old Ritik and his old Amisha. So when you go from top to bottom, that is from O to H, opposite and hypotenuse, we get sine. And when we divide reverse way, hypotenuse and opposite, we get cosec. Same way, if we divide adjacent by hypotenuse, we get cos. If we divide hypotenuse and adjacent, we get sec. Similarly, opposite and adjacent will give me tan, and adjacent and opposite will give me cot. These are the 3 and next 3, 6 in all, total 6 trigonometric ratios in our trigonometry. Even our next segment, we are going to see a chart of trigonometric table where we are going to see the values of trigonometric ratios for angles such as 0, 30 degree, 45 degree, 60 degree, and 90 degree in our next segment. Till then, goodbye, take care.